You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet, different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler 22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler 22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler 22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler 22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler 22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler 22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler 22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler 22b. That would be awkward if it turns out to be a gas planet, or something like that.
While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space. And aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigeon have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there. The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. Twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is. But we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the TESS satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot, 4-inch-wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry them there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
You shouldn't have made that bet with your friends. Now, your spaceship is hovering just over the atmosphere of Jupiter, a gas giant and the largest planet in our solar system. You're staring at the ginormous pale yellow sphere in front of your eyes, dreading your task, which is to fly through the planet and leave on the other side. Doubts are plaguing your mind. Is it even possible? Well, you're about to find out. Jupiter is truly massive. If the planet was 80 times as massive as it is now, it would have a chance to turn into a tiny red dwarf star. But even though its size isn't enough for such a transformation, Jupiter is still huge, more than 89,000 miles wide at the equator. The planet is so large it could fit inside 1,300 Earths. It's also impressively hot, about 43,000 F at the core. If you decided to parachute into Jupiter, you would never land on a firm surface because the planet mostly consists of gas. Around 90% of the planet's atmosphere is hydrogen. The remaining 10% is made up of helium with tiny traces of other gases. The planet is also surrounded by a layer of thick brown, yellow, red, and white clouds. They make Jupiter look colorful and beautifully striped. There's no solid ground on the planet. That's why astronomers define the planet's surface as the point where the atmospheric pressure equals that on Earth. You wouldn't be able to stand on that surface, though. It's just another layer of gases. but the gravitational pull there is around 2.5 times more powerful than on our planet. The deeper you dive, the more difficult it gets to move. Under immense atmospheric pressure, hydrogen and helium gases turn into a dense fluid. Closer to the core, this liquid becomes a mixture of metallic hydrogen and helium, which makes this region as exotic as the surface of the sun. Now, to imagine the gigantic pressure that exists near the center of Jupiter, think of the deepest place in Earth's oceans, the Mariana Trench. It's nearly 7 miles deep, and pressures there reach more than 1,000 bars. For comparison, at sea level, you feel the pressure of approximately 1 bar. But that number doesn't seem all that impressive when you think about the pressure at the center of Jupiter. It reaches up to 1 million bars. So, if you tried to enter that region, your spacecraft wouldn't just get squished or melted. No, it would simply disintegrate into atoms. You won't even have time to say, "Oops!" If you still decided to take the plunge, you'd have to go through different parts of the gas giant. First, you'd see wispy ammonia clouds. You might even enjoy a brief period of blue skies, due to the same phenomenon of scattering of light that occurs on Earth. After that, you'd pass through some red-brown clouds. Those are made of ammonium hydrosulfide. And then you'd see intimidating towering clouds lit by constant lightning storms. Way deeper, between 4,350 and 8,700 miles down, your spacecraft would enter an atmosphere so hot that it would be glowing. This is where the temperature rises up to tens of thousands of degrees F, and the pressure rises to megabars. That's also where your spacecraft is likely to start to disintegrate. This is a mysterious region of Jupiter's interior we know little about. It's still unclear whether the planet's core is a molten ball of liquid or a solid rock more than a dozen times the mass of Earth. It's most likely the former. There's even some evidence the gas giant's core might be melting right at this moment. Scientists have suggested that it consists of a mixture of materials, including nitrogen, carbon, and even iron. In any case, not to risk your life, you'd better admit you've lost the bet and return to your hospitable home planet.
When you explode planets, things get red hot. Atmospheres are pulled away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. But how can you do it? How can you blow up, let's say, Jupiter, the largest planet in our solar system? Thick brown, yellow, red, and white clouds hide its surface, making the planet look colorful and beautifully striped. First of all, we shouldn't forget that the gas giant's powerful gravity is holding it together, which is the reason for the planet's spherical shape. And we would need to add a lot of energy to blow it apart. But here's the problem. If we used some explosive material for our goal, it wouldn't be very efficient. A lot of energy would get radiated as heat in the process. The mass of Jupiter equals 318 Earth's masses, and about 1,000th of the mass of the Sun. The gas giant's diameter is also more than 11 times greater than that of Earth. It would be around a quarter of the distance from Earth to the Moon. So, can you imagine the enormous binding energy that keeps Jupiter together? Now, experts claim that to explode this space giant, you'd need a pile of nuclear explosives as heavy as 4 moons. Can you imagine it? Or let's take another unit. A highly explosive material known as TNT. How much of it would you need to blow up Jupiter? The answer is 50 megatons. And 1 megaton is 1,000,000 tons of TNT. These are some huge numbers. They also mean that if you made Jupiter out of TNT and blew it up, the explosion wouldn't produce enough energy to blow the planet itself apart. It would puff up more and more. But gravity would still manage to pull all the stuff Jupiter is made of back together. But let's suppose you somehow managed to find an enormous amount of explosives that would be enough to get rid of Jupiter. You hit the button, sitting in your spacecraft, hovering over the giant planet. Something is going on down there on Jupiter, but it's unlike anything that would happen to a rocky planet. Instead of chunks of solid crust, you see jet streams of gas accelerating away from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away into space turns liquid. That's hydrogen in its different form. Under immense atmospheric pressure, this gas becomes liquid closer to the center of the planet. A bit later, you notice that the liquid becomes different again. Now, it's a mixture of metallic hydrogen and helium. And finally, something solid. It might be Jupiter's core, which is 14 to 18 times the mass of Earth. The blast lasts no more than half a second. And still, the explosion is millions of times brighter than the sunshine. It's so powerful, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit. But it doesn't last long. How would the disappearance of Jupiter affect our solar system? For one thing, this gas giant shepherds the asteroid belt. And without Jupiter out there, the belt might grow unstable. It would lead to an increase in the amount of debris invading the inner solar system. Plus, the gas giant also acts as a sponge, absorbing rogue chunks of rock and not letting them enter the inner solar system. So, it's great that Jupiter is practically indestructible, unless it collides with an object as huge as the Sun, of course. Or you could probably scoop the planet up a bit at a time. It would certainly take a while. One hypothetical project called a Jupiter brain suggests taking Jupiter apart and turning it into a planet-sized supercomputer. And you know what? Some advanced technological civilization could probably do it, but not us humans yet.
Check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently. And if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity-to-weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal, with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury's the closest planet to the Sun, Venus is still the hottest one. Life on Venus, more like life on the Sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about minus 220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much.
Wow, you're zipping through space in a large ship as big as 3 New York City Central Parks. There's a lot of commotion going on. No, it's not some alien invading the spaceship. It's a very important day. The date is January 22nd, 2700. You've just been born outside of the Earth's atmosphere. Happy birthday! There's a medical team attending to everything. Futuristic gadgets help out with every aspect. And the view from the giant spherical glass ship is nothing but the incredible vastness of space. You can't even see Earth anymore. The spaceship is flying to a new destination millions of miles away. ETA on reaching that new host planet? Decades. Fast forward a bit. You're 25 years old, and this spaceship's the only home you've ever known. So far. You've learned all the ins and outs of the ship. You start your day in your dorm, which has all the essentials: a small compact bathroom, a mini kitchen, a bunk bed, and a magnificent view of the stars and planet outside the ship's reinforced glass. And you never need to worry about space radiation. The ship has an everlasting magnetic shield that reflects space radiation, so it doesn't seep its way onto the ship. Otherwise, there'd be big problems. The ship was designed to have artificial gravity. Astronauts normally lose 1 to 2% of their bone density every month they're up in space, since they're just floating around all the time. But now, I mean in the future, in deep space travel, they're able to solve this problem. You make your way out of your dorm and see a wave of fellow crew members making their way to work. They're all gliding through on their advanced mini hoverboards, and everyone's wearing different colors, a space-age uniform. Yours is blue, so you hop on your board and join the blue wave. You get to the underpass of the space transport and begin your work. As an engineer on board, your job is super important, maintaining the ship and keeping it running. But something's wrong. Numbers are flashing all over the panels, and the dreaded red light won't stop blinking. You alert your coworkers, but they don't know what's happening either. Quick, you keep checking the logs and all the complicated equations, but nothing adds up. Panic starts to spread throughout the ship. The hair on your arms is standing on end. You try to click on as many buttons and switches as you can. The buzzing keeps getting louder and louder. The light is flashing brighter. Some of your colleagues make a break for it, and you're all alone in the red room. Suddenly, finally, your supervisor rushes down to help. After a while, the two of you figure it out. Whew, that was close. You still have a lot to learn about managing the ship. Since your early years, you were assigned to work as an engineer. You were great at physics, chemistry, math, all those sciencey things. It's just another day in the office. But on this ship, you may make captain one day. After work, you get a call from your friends wanting to hang out. And when I say call, I mean a phoneless device that lets you communicate with anyone while seeing all their info through a hologram projection that only you can see. You can also use it to listen to old tunes from Earth. Pop music has now become classical music, and movies are now 3D projections of your own imagination. You make your way out of the underpass and go up to the Space Plaza. That's where everyone hangs out when they have time off. Some cafes, restaurants, a barber shop, even an ice cream parlor. You've never hung out anywhere else. The space transport is essentially a small city which has all the important things society needs. That includes a biosphere full of animals and plants from different climates on Earth. Many tropical forests, many deserts, many rainforests, you name it. The biologists on board make sure to keep it all healthy so you feel like you're at home. Not that you've ever set foot on Earth. You enter the wild savanna and see some gazelles galloping around. A few wildebeest seem to be rummaging around, and a small pack of lions are on the prowl. In the jungle, you feel the humidity and the thick leaves and bushes all around. Some mountain gorillas are playing, and there are little tree frogs here and there. And lurking in the trees, making its way down for a sip of water, is a jaguar. Over in the dry desert, you see some roaming camels, a little rattlesnake slithering its way out of the heat, and some little scorpions crawling around in the sand. You learned a whole lot of biology these last 25 years. You know all about Earth, but you've never been there. Weird. After the tour of nature's habitats, you hear an announcement on the PA. It's the captain. The new planet is hours away, earlier than anticipated. Everyone assume positions for landing. Everyone on the ship rushes to their dormitories, except the key crew members needed to run the ship. You strap into your bunk bed that turns into a seat with fancy interstellar seatbelts. You look out your window and see a blue dot in the distance. It gets bigger and bigger, and it looks a whole lot like Earth, from far away at least. That didn't take all that long, only 25 years. Wonder what's going under the hood of that spaceship. You look back at your life in space, knowing this first part of it is coming to an end. It's kind of like living at the South Pole. At the bottom of the world lives a small community of scientists who work between winter and summer doing all kinds of research, from climate and geology to meteorology and astronomy. Their lives must be similar to living here in outer space. They have their own bunkers, scientific labs, and even recreational rooms for sports and music. The nature on the planet you're approaching is unlike anything on Earth. Tropical trees soaring higher than the highest skyscrapers. Oceans that are so wild, there are hurricanes that last for years, just roaming about. The pilot announces the landing. It's all good. Time to get to work. You unstrap yourself and head outside to see the new planet for yourself. Walking on land feels like arriving on a new planet. The humidity is thick and the wind is warm. The ship landed on the tropical side of the planet, where studies show is the best place to begin a brand new settlement. It's not going to be easy. Humans usually begin new settlements next to lakes and rivers. Think of the Mesopotamians, the ancient Egyptians, the Aztecs. The list is endless. They began as small settlements until they grew to be fully functioning mega-civilizations. By trading and exploring, they were able to advance their technology, learn new languages, and discover awesome cooking recipes. Hey, I could go for some pasta and sushi right about now. According to scientists, being born in space could alter the way humans look. Human heads could be bigger within thousands of generations. Who knows? There's no way to simulate it on Earth. We can even have different new skin colors, since we would need more melanin, that pigment stuff that protects us from sun radiation. Being closer to the sun or any hot burning mass of fire might mean we'd produce more or different kinds of melanin to protect us. We might turn dark brown, purple, gray, or even green. We'd have to wait a couple of million years to find out. And with no gravity, humans would have to get used to having a lower bone density, kind of like birds have. That means we'd probably be weaker than our old Earth human cells and have some slightly odd physical things going on. Gravity is essential for our balance, and mobility is one of the key factors for human survival. So, without gravity, we'd most likely have exoskeleton suits for walking and running, or taking out the trash. Now, nothing like this is going to happen for a very long time. They're still brainstorming how to bring someone into this world, or out of this world. Technically speaking, outer space is considered to be 62 miles above sea level from any continent on the world. Beyond that, endless possibilities. Well, let's go to Antarctica. Come on, you've got time. Remember to dress warm. Here we are, in the middle of endless snow-white plains and ice. The temperature in some places drops to a face-freezing minus 136 degrees Fahrenheit. It's so cold that if you throw hot water out of a mug, it will most likely land in the form of an icicle. But this cold is hot compared to the absolute zero definition. Scientists measure it on the Kelvin scale, where 0 is the lowest point. And that's why there is nothing colder than this temperature. All objects consist of atoms and molecules. When the temperature of any object rises, its molecules move quickly and chaotically, producing kinetic energy. If the temperature of an object drops, its molecules slow down in motion, and their energy decreases. So, absolute zero is when the particles stop altogether. There's no movement, which means it's impossible to make it colder. 0 Kelvin is equal to minus 459 degrees Fahrenheit, so that's like 3 times colder than in Antarctica. So, imagine that scientists created a vacuum room and filled it with gas at absolute zero. What happens if a human walks in there? I can't imagine that this turns out well, so let's send Bob in there. But don't worry, he's a crash test dummy. A little background first. When a hot object comes into contact with a cold one, its molecules exchange energy. Fast-moving particles transfer their energy to slower-moving ones and begin slowing down themselves. Then an equivalent exchange occurs, and the temperature equalizes. But by default, the molecules move quite slowly until they're charged with energy. And at the same time, if you have a heated object, you will need more power to cool it. Yeah, it's a bit confusing. So let's go back to where the fun begins. Yes, if you go to absolute zero, you will freeze in seconds because all your molecules will start to slow down. But what will happen to the body? Well, let's follow the internal adventures of Crash Dummy Bob. First, its blood vessels narrow in the coldest places. The body distributes blood from frozen areas to vital organs like the liver, kidneys, heart, and brain. It's like emergency mode. The mannequin's body stores energy and blood for the most important, taking it away from less important areas. Then, a most dreadful thing begins. The body consists of billions of cells. When their molecules come into contact with a cold temperature, they slow down and freeze. Remember what happens to water in a frozen state? Remove the bottle from the freezer and let it defrost at room temperature. You'll see that the volume of liquid will decrease after a few hours, and when the water freezes, it increases in volume. And the human body is more than half made up of water. So, inside our mannequin, its cells get covered with sharp ice crystals that tear the internal structure of the cells. The muscles and blood vessels of the dummy are torn. Its skin gets a dark blue shade, and its blood freezes in its veins. A couple more seconds, and the dummy freezes completely. Absolute zero temperature stops all internal processes. Hey, Crash Dummy Bob said he wanted to chill, but this is ridiculous. Meanwhile, molecules are not only in living objects. Particles are everywhere, and absolute zero affects them too. The rays of light get the lowest energetic position. Photons slow down, and they can't move at the speed of light anymore. Okay, now it's time to finish the experiment. Something's going wrong, and the story becomes fantastic and hypothetical. Scientists can set molecules in motion, and the neighboring moving particles don't give them their energy. For some reason, the gas can't absorb the energy. Its frozen molecules slow down the others. The gas penetrates through the walls of the vacuum room and starts a chain reaction. The molecules freeze one by one. It's like they take a nap and charge all the matter around with this sleep. The gas area is expanding. Laboratory walls, doors, and windows are frozen. Scientists are covered with ice. Then the cloud goes outside the building. It's like a white spot that keeps growing and growing. The sun's rays get there, but can't move inside too fast. The zero envelops grasses, trees, roads, and cars. Scientists begin to sound the alarm as soon as a whole city gets inside the absolute zero clouds. The stopping of moving molecules occurs so fast that ice crystals don't have time to damage the skin and body in living bodies. It's not even freezing, but canceling existing life. Oxygen and carbon dioxide molecules are frozen. The air gets denser. Here a guy freezes in a jump and remains in the air. Here a frozen bird continues to hang in the air. Things inside the cold air are similar to a 3D picture. Everything froze in motion. It's like someone took a screenshot of a lifetime and printed it. And while the cloud of absolute zero continues to spread, scientists are rushing to solve the problem. The gas is growing and diverging in all directions. If it swallows the whole Earth, it will stop all the chemical processes on our planet. And without these processes, our home will become just another space rock, a lifeless piece of matter stuck in time. However, the real catastrophe will happen not when it envelops the entire surface of the globe, but when it reaches the core of our planet. This can lead to the release of energy that will destroy the planet. Perhaps the core may resist the absolute zero, but in any case, people are not going to wait for this to happen. The cold gas meets a volcano. Lava flows emit a deafening hiss and freezes. Black clouds of steam billow into the air. The cold cloud penetrates into the volcano. The collision of cold and hot temperatures releases energy. The volcano erupts and launches not fireballs, but sharp icicles of frozen magma. Meanwhile, heavy rains are beginning to fall all over the planet. When warm air collides with cold air, it moves away because it has less density. The liquid appears in the atmosphere and it forms clouds. Therefore, while the giant cloud freezes one part of the planet, rain clouds drench the other. And now scientists have finally come up with a solution. They've created a gas with an altered molecular structure that can stop 0 Kelvin temperature. So imagine you're heating water. The stronger the water molecules increase their kinetic energy, the hotter the water becomes. The molecules are moving faster and faster, but not all particles move equally fast. Some of them have medium and slow energy. Moreover, the low energy state of the molecules is more likely. This means that only a few particles move really fast in hot water. This distribution of low and high charge particles is called the Boltzmann distribution. The distribution is everywhere, both in hot and cold objects. If we look at any object at the molecular level, we'll see that there are many more slow-moving objects than fast-moving ones. So, scientists have come up with a solution. They create a gas that works in the opposite direction. It has more moving molecules inside this gas than slow ones. Scientists hope that this gas will wake the sleeping particles up in the absolute zero cloud. So, two gases collide with each other. The cold cloud can't freeze the reverse Boltzmann distribution cloud. There are too many active molecules. So, billions of active molecules charge the frozen ones with energy. All the molecules start moving and share the neighboring ones with their energy. Objects inside the gas cloud begin to wake up. People are slowly coming to their senses. As soon as the molecules come into minimal motion, they start to receive energy from the sun's rays. The particle movement is distributed equally between the two gas clouds, and life returns to normal. The molecular order has been restored. Right. And our little fable here comes to a happy, if not entirely credible, end. Bottom line here, don't worry. Scientists created absolute zero artificially, and it'll never happen naturally. There's no such temperature anywhere in the universe. Particle movement remains even in space's farthest and darkest corners with record-low temperatures. The appearance of absolute zero is impossible because there will always be molecules around that move and share their energy with each other. Oh, by the way, no humans, animals, or Crash Dummy Bob were harmed in the making of this video. Are the lawyers happy? Okay. Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, And you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission: to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky. Folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky, but its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain, and right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. in maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.